Now, hello everyone again and welcome to this particular video where we're going to explore specific heat capacity of a specific material. And looking at this question, we are going to dive into determining the energy that is absorbed by a specific material, in this case iron. And iron is going to be subjected to heat, increasing its temperature, transforming it from solid state at normal temperature conditions to the liquid state, which is pretty much melting point stage. Getting those two temperatures alongside the specific heat capacity, which is the amount of heat to increase 1 degree Celsius of 1 gram of a specific material. So looking at those and also the mass given, we will be able to actually go into the following step, which is first analyzing this particular question. The way I analyze it specifically is to actually look at the givens. So the first given is the mass of iron, which is 75 grams. We have the specific heat capacity of iron to be 0.449 joules per gram per degree Celsius. And then we have the final temperature to be around 1535 degrees Celsius, and finally we have the initial temperature to be 25 degrees Celsius. Now you've written those, we need to come up with the analysis, which is pretty much the energy absorbed or released. In this case, for the purpose of this particular video, it is the energy absorbed, which is Q, which is also equal to the mass multiplied by the specific heat capacity of the same material mass, and the temperature change. Take note that the temperature change is actually linked to the units, which is in degrees Celsius, not in Kelvin. Reason is because looking at the specific heat capacity, the unit in there is in terms of degrees Celsius with respect to the temperature. So in this part, what we actually come up with is that we have 75 grams multiplied by 0.449 joules per gram per degree Celsius for the specific heat capacity of iron, and then for the initial temperature and the final temperature, we know the final temperature to be 1535 degrees Celsius minus the initial temperature, which is 25 degrees Celsius. So if you solve that particular algebra or simple mathematics, we actually come up with a subtraction which results in 1510 degrees Celsius multiplied by the specific heat capacity of iron and also the mass of iron. And so once you cancel out the units, you actually come up with the multiplication result, which is around 50,849.25 joules, which is the energy absorbed by iron to actually melt it from normal condition, which is 25 degrees Celsius, which is incredible. That much energy in there. And so the question actually follows up with, okay, how do you transform this particular number that is in joules to calories, or specifically the shorter form is cows? We know from the specific heat, from standard unit or conversion, that 1 cow or calorie is equal to 4.184 joules. So if you do your simple proportion, you notice that to determine the energy absorbed in cows or calories, we actually do our specific arrangement, which is 1 cow divided by 4.184 joules multiplied by 50,849.25 joules divided by 1. So once you multiply that or those fractions, what we arrive at is the amount of energy in cows to be equal to 12,153.26 calories. That is equivalent to 50,849.25 joules. So that is about it for this particular video. Hope you're able to understand how to actually break down specific questions into smaller chunks, that is using the specific heat capacity and also the Q, which represents the amount of heat absorbed or released, to actually express what energy is released based on the temperature change and the mass. Please hit the like button, share and subscribe, and let me hear your thoughts about this in the comment section. By that way we can actually explore more really deep and answer your questions. All the same, stay smart, believe in yourself, and see you on my next video.